Thevenin theorems and Norton's theorems are most important in circuit analysis, especially whenever complicated circuits uh, appears. These theorems will help to solve such complicated network. Consider one example here. This is the one questions appeared in a previous question paper. Vishweshwara Technological University, Belagavi. So in that, this questions appears. Here, obtain Thevenin and Norton equivalent circuit at the terminals AB between these two terminals and find the current through 10 ohm resistor across. If I connect this 10 ohm across this, find out the current also. This is the question. So the circuit, it is one current source with a magnitude of 5 and a 30-degree angle going upside. In complex network, its impedance is 5 plus j5 ohm and 10 ohm resistor. And again, this is also 5 plus j5. So I have to replace this circuit by single voltage source in series with the single impedance for this Thevenin. And coming to the Norton's, single current source with single impedance that is in parallel with the current source. This is I have to do. So we'll take a first step. And again, solving this, can I first replace this by Norton or Thevenin? Some of the circuits, it is better to go for Thevenins, or some circuits, it is better to replace by Norton. So now I am going for a Norton's replacement, first step. Just I have shortened here. When I shortened, why it is easier, okay, when I replace it to Norton's, because this impedance becomes 0. Yeah, this is impedance is 0. Yeah, then in that case, in place of this, simply draw a one shortened term. What Norton's theorem says, those two terminals we have to short circuit. That is, I have to find out the short circuit current first. So I am going to find out this short circuit current IN. This is the equivalent of this circuit, because this, when I shortened here, this will not come into existence. Now I have to find out this IN current. Current though, here there are two branches here. One is this branch, another is the second branch. You call it as a first branch and second branch. I have to determine the current through the second branch. And there is a single current source here. So this IN is equal to whatever the current here, 5 into 30 is the into impedance of the other branch, into impedance of the other branch divided by sum of this branch. You call it as Z1 and Z2, Z1 plus Z2. That is 10 plus 5 plus J5. This, I will convert this rectangle to polar, and this also I will convert it. The reason is easy for division. Whenever a division operation, multiplication operation comes, complex can be replaced with the polar form. This step I did. Our calculator, some calculator may support directly, need not to convert this. So I did this, and dividing, this will be of 2.236 with the magnitude of 56. This is the current source, Norton current. Next is impedance, Thevenin's impedance between these two. Here, it has only one current source. I will remove this one. Current sources are to be removed. Voltage sources should be short circuited. That is the procedure in Thevenin or Norton's theorem to determine the impedance here. Now I am removing this. There is a current source. I am removing this. If there is a voltage source, then I have to short circuit here. Yeah, this is the impedance here. And look at this 10, 5, J5. This is in series, and these two are in series. And this you call it as a Z1 and Z2. So Z1 into Z2 divided by Z1 plus Z2. 5 plus J5, 10 plus 5, 15. So conversion, okay, convert this into polar form. Convert this to polar form. Or okay, directly calculator supports, you can do these operations. But in my case, I just converted into polar form. Then the impedance is 5 with angle of 36. This is the Norton's here. First I determine the Norton, then Thevenin's is IN into Zn. IN into Zn is this one. So 11.18 is the voltage. This impedance will be come into series. So now the first step is over, replacing the given circuit into Norton and Thevenin. Last step is determining the current when 10 ohm is connected here. So this is the one. 11 point is a V, and these two impedances. I just converted this into rectangular and again polar because division here, or if calculator support directly, you can skip these two steps. This is the current. In this way, you can replace the circuit and also determine the current.